Hello. So we're going to be looking at linear and exponential models comparing the growth rates. So just wanted to show you where we're coming from. We're in this module book, Enrica Math. Anybody who does that. Otherwise, you can just kind of watch what's going on and uh, hopefully this all makes sense to you. So these are exponential graphs because they have a little bit of a curve going to them. So they are exponential functions, and we're going to look at certain problems. So my students, while I'm out, you're going to be following along and taking notes as we go. So this specific chart that we're going to be filling in says a lab researcher records the growth of the population of a yeast colony and finds that the population doubles every hour. So we're doubling this. So this is kind of an easier graph for you guys. So it's the initial value here is 5. See, it's at 0. And at 0, we're already going up to 5. So see 0, 5. That's just kind of giving you a hint of what 0, 5 looks like. So 0, 5, 1, and remember it doubles. So this 5 becomes a 10. And then we double 10, which becomes 20. We double 20, which becomes 40. And we double 40, which becomes 80. So that's how we double this. Now, that's how we would fill in a chart based on whatever it's asking. This is really no different than something you did, say, in like 6th grade. If you need the graphing calculator, you can totally use the graphing calculator. But now it says, what is the exponential function that models the growth of the colony's population? So if you look at the last page that you just did, I'm just going to use p to the t because we're talking about thousands and we're talking about population in thousands equals. So we're going to, the starter value, the number that's under the 0 was a 5. So that's our starter number. And they said that it doubled. And you have to realize that double means 2. So the pattern's inside the parentheses. And as we know from our FV/PV formula, future value, present value, that the t is our exponent because we are making exponential things. So if we were to put in the 0 here that we had, 2 to the 0 power is 1, and 1 times 5 gave us the 5 in the chart. If we were to put a 1 here, 2 to the first power is 2. 2 times 5 is 10. If we put a 2 here, 2 to the second power is 4. 4 times 5 is 20. If we put a 3 here, 2 to the third power is 8. 8 times 5 gave us the 40. And if we put a 4 here, 2 to the fourth power was 16, and 16 times 5 gave us the 80 that was in our chart. So that's how we establish this formula, this being the pattern, this being the starting point. Okay, so we don't really have a lot of examples that we are going to do, but this video is going to help you on your homework. Okay, so we actually are going to take a peek at our homework. So we could keep doing these other ones underneath it for example, but they didn't give us too good of examples. They give us some that have like a square root or a cubed root, and they didn't give us anything that really could help us out and make a lot of sense on what the New York State Regents would give to us. So we're going to take a jump right to where our homework's going to be. And we're going to talk about question number 1. So it says, when a ball bounced up and down, the maximum height it reaches decreases with each bounce, and it bounces in a predictable way. Suppose for a particular type of squash ball dropped on a squash court, the maximum height of h of x after an x number of bounces can represent. All right, so we're basically just kind of figuring this out. Maximum height it can reach, decrease, and then they give us this formula. So that means that 65 feet is basically where it's at, and it's decreasing at a pattern. So it says the maximum height it reaches decreases with its bounce. So this is the maximum height, and it's decreasing by a third for each bounce it takes. So the x is the number of bounces. So it says, how many times higher is the height after the first bounce compared to the height after the third bounce? So then we actually put this kind of thing into our formula. So if everybody has their calculator, so everybody get a hold of their calculator. I'll give you a moment for that, because you just pause the video so that you don't accidentally, it keeps going and you don't really want it to. So everybody do that. All right, so if that gave you enough time to grab your calculator, now what we're going to be doing is how many times higher is the height after the first bounce compared to the height after the third bounce. So now we have to take that equation, okay? So here's some function stuff. So we have the big 65 in the parenthesis, and then we can go alpha x or alpha y. It's up to you. If you do alpha y, you have to pick number 1. Or if you do alpha x, it just gives you the regular flashing top and bottom of a fraction. So you go 1, you arrow down, you put a 3, you arrow over to get out of it. You put a parenthesis, and they want the first year. So that's 65 thirds. And then you do it again, 65 parentheses, alpha x, 1, arrow down, 3, arrow over, parentheses, caret third. You get 65 27s. So if you really think about this, the 65s are the same, but 3 goes to 27 by how many? That kind of gives you a trick that's 9, roughly 9 times. So 9 times greater. But another way to look at this, and we can actually do the math and go 6, because we know that the fraction means division. 65 divided by 3, enter. 65 divided by 27, enter. And so we want to know how many times greater, but when we subtract these numbers, or you can just literally go 65 over 3 minus 65 over 27. So when we take roughly 21-ish or even 22, or we go 21.6, it really doesn't matter, 2.4, we get 19.2, and we can't really go 10 times greater because 10 times 2 is 20, but we can get 2 into that. We can get a 9 into that twice. So 9 is the biggest we got because it doesn't exceed it. Okay. All right. So now if we're looking at how we graph these, so this right here, how we graph these is it says h comma h of x. So we just know that h of x is a fancy word for y. We always know this. So this is nothing more than an x comma y graph. However, when we're putting all these, we would have h of x equals. And what we're doing is we're putting in the 0, putting in the 1, putting in the 2, putting in the 3, putting in the 4, and putting in the 5, and you're going to graph that. Okay, that's something you're still going to do for homework tonight. I'm just leading you up to your homework. So if you forget, you can come back. But you're going to be graphing those. Okay, you do not need a fancy calculator for this. You can use your cell phone calculator. You can use Desmos on your cell phone. You can use a basic one in a study hall. You'll have plenty to be able to do. Now, looking at question number 3 that we're going to look at. Let me move this up. Here we go. Now, this one's just a little bit different. So, it says, after graduation for college, Jane had 2 job offers to consider. Job A is compensated at $100,000 per year, but with no hope of ever having an increase in pay. That means you're never getting any more money. And we're just looking at the top one. You're not getting any more money than $100,000. Okay. And that's job A. Job B, you're guaranteed just a whole $10,000 a year, but the founder is sure the concept is going to be a big thing, so it promises you to increase it by 25% each new year. So this is like a flat $100,000. So we can be like job A, flat $100,000. Okay. So now job B is going to be that FVPV formula. Okay. So our present value, and I'm just going to write this equation here so you see it. So we have our future value equals the present value, which is $10,000. We're going to get an increase, so we have the 1 plus the 0.25. Now remember, 25%, two jumps, and that's for each year. So that's like the T time. So that's like 1 year, 2 years, whatever they ask, you keep fixing it. So it says, which job will have a greater annual salary at the beginning of the 5th year? So we know that the beginning of the 5th year, job A is just this. You're not getting any money. This is what you got. But now what we do is we check this formula for job B. Remember, this is job B. And we see which one's greater. So I'm going to start you with this so you can see this happening. We already know that money. Now let's put in this one. So we have 10,000. And then we have parentheses, 1 plus 0.25 parentheses, caret, and it says 5 years, the 5th year. So this one says 30, let's see, did I get that right? Oh, sorry, beginning of the 5th year. My bad. So rewind. Okay, there we go. So we have this much money because and this is at guaranteed a mere guaranteed 10,000, and then you have beginning of the new year. Okay, let me see. No, actually, I was right on the first one. So skip our last ones, kiddo. We want to go with that first amount of money. For some reason, I thought that decimal real quick was a comma because I was looking at my screen and not looking at the actual screen. So we take this much money, $30,517.58. So when we're looking at that, which one's more money? Is it job A or is it job B after 5 years? And we know that after 5 years, obviously job A is still going to be more money. So job A is more money. And we can approximate that by, we had 30,000. So 70,000, basically 70,000, right? And remember, it's approximately. So like ish. We can do a little ish on that. So this is how you're kind of figuring this, okay? So which job will have a greater annual salary? Then we do the same thing again, but this time we have to do the 10-year mark. All right, so I'm pretty sure that you understand the concept of how this one would go. So we're not going to actually do any more on this. So the only homework that you guys are going to do tonight is I'm going to have you graph the items from the first question that we did. Okay, so you're going to actually graph these, and then you'll have the answer key with the substitute just to check your number one. Okay, and as always, this is Miss B. I love math and CrossFit and Diet Coke.